All right. Our next section is 7.3, and it's titled Volumes of Revolution. So we're going to talk about taking 2D spaces in the XY plane and rotating them 360 degrees around some axis. Hopefully you got an idea of that from the YouTube video where the figure, the 2D shape, rotated 360 degrees around the x-axis, and that's where we're going to start with this. So something very similarly to that, we're going to look at the function y equals the square root of x, and we're specifically going to look at that from 0 to 4, and so that area would look like this shape. Okay? And we're going to try and spin that 360 degrees around the x-axis. And we're going to then try and calculate the volume of all the space that that shape comes in contact with, which would create a 3D figure. A picture of what that might look like would be something maybe like this. That looks pretty decent. Okay, so we would have this, and it's hard to give it depth in a 2D space, but that would be kind of like a thimble type shape that we would be looking to find the volume of. Okay, so to imagine finding the volume of this shape, we're going to look at it as though it's been sliced up into a bunch of shapes like this. That doesn't get us where we want to be. Something similar. All the way around, right? That's a 3D slice of our thimble or whatever. So how would we find, like, what shape does that kind of look like? And we would say that it kind of resembles a cylinder. And so we might consider how you find the volume of a cylinder. And that is actually equal to pi times the radius squared, the area of the base, and then multiplied times the height. So we have to ask ourselves, well, how would we find the radius of that cylinder? And I would say, well, it'd be really from from the center of our circle out to the edge would be our radius. So then we start to ask ourselves, well, what would we do to calculate that radius? And really, that radius is equal to our function value at whatever point we happen to be at. Okay? And then the height of that would really be kind of the side-to-side space. It actually kind of looks like an H. I'm going to call it capital H. I meant to show kind of the interval of height right there. And so it's that space, that will be our height. And we really want to look at minimizing that and creating as small of height discs here, cylinders, as possible, and then stacking them on top of one another so we can create the volume of this shape. And we want to minimize those intervals to be as small as possible. And when we look at very small widths underneath a curve, what are we really referring to? We're referring to dx. Okay, so our volume formula then to find a volume of revolution is going to be equal to the integral from a to b, starting point to ending point, of pi times whatever the function value, which is really going to be our y value squared, dx. Okay, remember that y is the radius. Okay, that's our distance from the axis up to the function, and then dx is our small height or small change in x. Okay, so let's grab, oops. Let's grab this. And let's calculate our volume. So if we took, to find this volume, we want to do the integral of pi times y squared dx from a to b. Well, that would really be equal to the integral from 0 to 4 of pi times our y value is really going to be square root of x, wherever the x value is. We would square that dx. If you were confused about why we had y squared dx in there, now I think you see that we really always represent what y is in terms of x, and so that would be, that y value is going to be expressed in terms of x, hence the dx. So now we just need to simplify this. I'm going to come up here, and really we know that pi is a number, and we've always said we can take constant numbers out in front, so that's what I'm going to do. We're going to go from 0 to 4, and then the square root of x squared would just be x dx. So then we're looking at taking that integral, and the integral of x would be 1/2 x squared from 0 to 4. And so finally we would plug in, and we would see that it would be pi times 1/2 of 4 squared minus 1/2 of 0 squared. 4 squared is 16. Half of that would be 8. Our answer would be 8 pi units cubed, because that would be the volume of our thimble. And so that's how we find a volume of revolution, by taking an equation and revolving it around the x-axis over a certain domain.